Okay, so problem 77 from chapter 3 says a football quarterback is moving straight backward at a speed of 2 meters per second when he throws a pass to a player 18 meters straight downfield. The ball is thrown at an angle of 25 degrees relative to the ground and is caught at the same height as it is released. What is the initial velocity of the ball relative to the quarterback? So here's the velocity of the quarterback going backwards. That's relative to the ground. That's 2 meters per second to the left. And we'll draw the velocity of the ball. It's up and to the right. It's 25 degrees above the horizontal. And the path of the ball will be up a parabola, and it'll go a distance of 18 meters before it's caught at the same height. So that's the range, is 18 meters. And I don't know if you remember, but in the last video, the lesson 8 video, we solved this to be r is v squared sine 2 theta over g. That was the range. Where in our case, this v0 is the magnitude of this initial velocity of the ball relative to the ground. The theta is going to be 25 degrees relative to the ground, and we know the range is 18 meters. So we can solve this equation for vbg. So writing it out again, r is vbg squared sine 2 theta over g. We can multiply by g, divide by sine 2 theta to get vbg squared, take the square root. It's the square root of rg over sine 2 theta. And plugging in the numbers, it's the square root of 18 times 9.8 over sine of 2 times 25. Plugging that into my calculator, I got 15.1748 meters per second. Okay, so VBG is 15.17848 meters per second, 25 degrees above the horizontal to the right. We want to figure out VBQ, the velocity of the ball relative to the quarterback. So let's use VBQ is equal to V plus V something else. The outer subscripts will be B and Q, and the inner subscripts are the third object, the ground. So that's what the equation looks like. We don't know the velocity of the ground relative to the quarterback, so we'll put it in the negative there, quarterback relative to the ground. So let's just draw this out. VBQ, so V, that's supposed to be VBG, and negative V quarterback ground. Those two things add up to be velocity of the ball relative to the quarterback. So we'll just use components. We'll set up y as vertical, x is towards the right. So the negative of the velocity of the quarterback relative to the ground is plus 2 meters per second. In the x direction, and in the y direction it's 0. As for the ball relative to the ground, we'll have to actually draw that out. There's your 25 degrees. We've solved for the magnitude was a 15. So it's VBG cos 25 is the x component, and VBG sine 25 is the y component. So the velocity of the ball relative to the quarterback in the x is the VBG cos 25 plus 2. Plugging in all the numbers into my calculator, I got 15.75302 meters per second. And in the y direction, you got VBG sine 25 plus 0, and I got 6.4131 meters per second. So those are the components. If you want to find the magnitude, you'd use Pythagoras, take the square root of the sum of the squares of the different components, and I got 17.0084 meters per second. To find the angle, it's use tan to the negative 1 of the y component over the x component, and I got 22.1515 degrees. So to sum up, the velocity of the ball relative to the quarterback is 17 meters per second, 22.2 degrees above horizontal towards the right.